Um, Today, we're going to start off with a really fascinating session. There's a pre-record, and then we're going to have a little bit more of an extended question and answer session afterwards. I'm really excited about this one because it's something that I think will play a part in some conversations that we have to have on our own team about about how we structure and think about our own applications with all the different things that our company does. But George Faltas is an Android staff developer at Loblaw Digital. He's development experience with back-end and front-end technologies. In his spare time, he enjoys coding, drones, DIY, home renos. More power to you, George. I can't wait to hear more about we're going to talk about today with these like little applications inside big ones. Please welcome George Faltas, everybody.
Hi, my name is George Faltas. I'm an Android staff developer at Loblaw Digital, working with the PC Optimum loyalty team. I want to present to you a relatively new idea in the mobile world called super apps. A super app allows users to interact with different services through a much more integrated experience. The idea of integrated experience is not new in software and has been around for a long time. Many software today already do this. For example, Slack or WordPress allow third-party developers to build integrations and plugins that extend the capabilities of their software and add utility. You can think of Slack and WordPress as a type of super app, and the plugins integrations as a sort of mini app. Applying this analogy to mobile apps, a super app would be a native application, and mini apps would be the integration plugins that extend the capabilities of the native app. However, unlike web applications where new features and services can be added and deployed to a server at any time, the delivery of features and services on mobile is fixed at compile time, meaning once an app is built and uploaded to the Google Play and Apple App Store, the features in that build cannot be changed. Super apps, on the other hand, allow for dynamic delivery of new features and services through mini programs, and yet feel integrated with the native app and the operating system. This mini application can access services and features that the host application provides. For example, payment, camera, and other sensor information. Another benefit is the download size of the native mobile app. It is smaller and users don't need to have unused code or features on their device. Let's review the current mobile app landscape by comparing super app versus traditional standalone apps. The first category of mobile apps is standalone apps. And this is what most of people are familiar with. They are downloaded from the Apple App Store or Google Play Store and primarily focus around a single purpose, like messaging, calling, or streaming. The second category is app suites, and they're a collection of apps by the same developer, and because they trust each other through digital certificates or signatures, they can share data with each other. The third is called super apps, and these offer the users the ability to interact with different lines of business by the same company, like payment, commerce, and communication. Paytm is a good example of that. Mini apps in this case are primarily developed by the same organization that owns the super app. The fourth category of mobile apps are called super apps plus mini programs. And these are it's a single native app allowing third-party developers to develop programs that run within the app. Example, WeChat, Alipay, and Badu. Here are some recent news and headlines that indicate a trend towards super app. Previously, 3 apps from Wealthsimples were required to use all their services. The new Wealthsimple app allows making deposits, access to investment accounts like trading stocks, ETFs, and crypto, everyday spending account, registered accounts, RRSPs or TFSA, all can be accessed from within a single app. WhatsApp launched the shopping experience, allowing people in India to browse the JioMart catalog, add products to their cart, and pay for purchases all within WhatsApp. Shoppers can add items to their cart, make a payment to complete the purchase, all without leaving the WhatsApp chat. Uber has integrated Uber Eats in their app. Within the Uber app, you can request a ride, you can order food, you can deliver a package, and pay for these services all within the Uber app. These different services all integrate with the Super app while maintaining a consistent look and feel and user experience. User identity, payment, and session are all seamlessly integrated. The user does not have to leave the main application. But how do we justify doing this work? What are some of the cost savings and business benefits to doing this? 1, bringing awareness to other lines of business and cross-sell. With any new digital business, the customer base might be relatively small or non-existent when compared to the Super app user base. The Super app is a great way to drive awareness of services and creating additional pathways for users to transition shop to other lines of business. Second, increasing digital engaged members and incremental sales. The ability to integrate features and services dynamically via mini apps within the existing ecosystem, partner ecosystems, or third parties creates the necessary foundation in the app to add utility that would drive visits to the app. Third, reduce customer friction. In the current single app model, users would have to install numerous apps to access all the different services. The Super app consolidates numerous services, making it easier for users to access them in one place. And fourth, lower the cost to acquire new users for new businesses. This is especially true if most of the new users are already your customers for other services. As previously mentioned, Super apps integrate the best of native apps and web apps in that mini apps will load dynamically. There is no prior download or install required. Mini apps can integrate to all the functionalities and resources of the device. They also do not have to go through the native app approval process for them to be published in the store. To summarize these points into one goal, can we build native mobile apps and still maintain the dynamic delivery of web? Again, the question is, can we build native mobile apps and still maintain the dynamic delivery of web? For the remaining part of this presentation, I will be sharing with you our journey, thought process, and solution. Take a look at this screen. There are UI elements that native app users are familiar with. Notice the toolbar with the title, the hamburger menu, action buttons, and the overflow menu. The interactions of these UI elements are also sometimes unique per platform. For example, on Android, a click of a button might produce a ripple effect, while on iOS, it might change colors. These UI elements and their interactions are not typically present, required, or standardized across websites. Integration with device hardware is the second consideration. Native app developers have direct access to the native hardware, like camera, sensors, geolocation, device storage, etc. On the web, support for device hardware varies depending on the browser. Third, responsiveness. Native apps are known for their quick and snappy user experience. Unlike websites, native apps only have to retrieve data and content from their remote servers, while the screen layout, theme, and logic is loaded immediately from the device. In our search for a mini app solution that was consistent with the native look and feel, integration with device hardware, and responsiveness, we first started with just directing users to a mobile-friendly website as a quick way to promote other lines of business directly from within our app. But the user experience and native integration was lacking. We also considered if mini apps can be built natively, even if it meant developing mini apps separately for each platform. As it turns out, Android has dynamic feature modules. Dynamic feature modules allow you to separate certain features and resources from the base module of your app and include them in your app bundle. Users can download and install these modules later on demand after they've already installed the base APK of the app using dynamic delivery. Issues with this approach. iOS does not have dynamic feature modules, and so we would not be able to support mini apps on iOS. It's not cross-platform. Again, separate development effort per platform unless we wanted to leverage Flutter. It does not meet the no download requirement, meaning users would still have to download the app at runtime and store it on their device. We considered several hybrid mobile app frameworks as well. React Native, Flutter, Xamarin all had a lot of great cross-platform features, but all required app store deployment, and some had a high learning curve. However, Ionic hybrid mobile app framework stuck out from the rest. Ionic is an open source UI toolkit for building hybrid mobile apps using web technologies, HTML, CSS, and JavaScript. Ionic provides pre-built web components that mimic native UI component interactions, gestures, and animations. It has integration for popular frameworks like Angular, React, and Vue, which reduces the learning curve for developers because they can get started with the technologies they are already using and are most familiar with. Access to the native OS and hardware APIs is facilitated by Capacitor. Capacitor is an open source native runtime for building cross-platform iOS, Android, and progressive web apps with JavaScript. Plugins in Capacitor enable JavaScript to interface directly with the native APIs. Web developers invoke and interact with the native platform using JavaScript. Capacitor has many official and community-based plugins and allows for custom plugin development if necessary. Check their website for documentation. Revisiting our question and requirements. Can we build native mobile apps and still maintain the dynamic delivery of web? The answer is yes, we can. By leveraging Ionic and Capacitor, we can build hosted mini applications and render them in our super app. Our mini apps are web applications that look and feel like native mobile apps. By hosting them on a server, we can remotely add, remove, or update them. This diagram displays the architecture difference between native apps and Ionic-built mini apps. The pink represents the native components and the blue the web components. Native apps, on the left, have less layering and interact directly with the native hardware and OS. The source code is compiled and is optimized for the hardware architecture. Ionic mini apps on the right are written with HTML, CSS, and JavaScript and rendered in a native web view, which is a web browser embedded in a native application. On iOS, the WK web view is used to display the mini app, while on Android we use the web view. HTML, JavaScript, and CSS is not compiled, but is interpreted at runtime. Access to the native OS and hardware API is via Capacitor plugins and bridge layer, which marshals data between the web app, web view, and bridge layer. Please keep in mind that there is a performance trade-off as a result of this architecture. The software layering, marshaling of data, the runtime interpreter, deployment options used, all impact the performance of the mini app. There are 3 steps to the deployment of a mini app. First, the APK or IPA file are uploaded to the corresponding store for approval. Bundled with it is the rendering and runtime environment that allows for JavaScript to interface directly with the native APIs. Second, mini app administrators configure and authorize each mini app. Mini apps integrate the mini app JavaScript library required to invoke the native plugins on the device and are deployed to a web server. If mini apps have been authorized by the admin team, it will display in the super app. The first business we integrated as a mini app in our PCO super app was Marketplace. Marketplace is an e-commerce store that offers Loblaw customers an assortment of products. So with all these pieces in place, here's a demo of me launching the PCO super app and opening the Marketplace mini app application and adding a Christmas wreath to my cart. Okay, with the demo app out of the way, let's shift towards security. Super apps should enforce domain restrictions. The super app implicitly trusts mini apps because the native capability is registered to the browser. It is important that mini apps are careful with sensitive data and restrict the domains that they allow users to navigate to. Here are some good practices. Plugins should be removed for domains that are not part of the mini app. Remove objects from the JavaScript interface before untrusted content is loaded by the web view. Ensure the file and HTTP path are validated against trusted path. Disable clear HTTP text. There were a few more technical details that we needed to be addressed as part of mini app development. We needed to manage single sign-on across super app and mini apps. Second, we needed to account for the scenario where the mini app required customer information during registration and onboarding that was not available to the super app. And third, plugins and the capabilities they provide can change from version to version. In a distributed environment where mobile users can be running different versions of the native app, a mini app can break on devices that does not have the capability provided by a plugin. So a migration and update strategy will be required to detect and handle this. Okay, that's it. Thank you for joining me today as I shared with you Loblaw Digital's journey with mini apps, the technology we used to build them, and some of the technical obstacles we faced. A special thanks to FITC organizers for allowing Loblaw Digital to be present at this event and for allowing us to be amongst such great company. Thank you.
Oh, that was awesome. George, I can't tell you like how topical this is, just because we have so many different things going on at our company. It's that figuring out a way to bring those things together has really been a challenge. Just, never mind the engineering of it, just from my own perspective as a designer on the design system team, like how do we think about these things with different branding and different functionality and stuff and still try and bring those things together. So before we dive into the questions, and we've got a bunch through a couple different channels now, how are you feeling about this ecosystem now that you've had a chance to do a couple of apps with it?
Yeah, so we only built one app, so just from it's not a couple of apps. So we are working on a second app at this point in time, and so I think from a technical perspective, I do believe it's a good solution. It allows us to operate and have the super app team operate and continue to build great features natively and support these mini apps by building components that they can use and invoke. It allows the teams to operate separately. And so you can have the mini app development team continue to build features that are related to their line of business, and allows us to continue doing our own work independently. So it's a great way of working. And so as these mini apps or different lines of businesses come online, they could operate and work towards their goals and their objectives independently. And we could support them by allowing building these native capabilities. So I think it's a smart way of working. We could continue to roll out the native application and build our own features, because the native app itself is its own line of business, it's loyalty. And so we can operate and work it very much in an independent fashion. So I think it's a great solution. I think time also is an element of anything. It really determines whether or not the decisions we've made prior and the research and the homework that we did, whether or not it will pay off, right? And I think it's going to take time to really prove its worth, like any technology.
So one of the things that, let's see. Gosh, so many questions. All right. So before I feel like a couple of the questions sort of dovetail with things that were on my mind, and I feel like that's going to be a pretty deep well for us to get into. Let's maybe start with why not progressive web apps? Why mini apps? Like, what's the distinction in your mind there, and the pros and cons of doing an approach like that?
Yeah, so it's one of those things that I struggled with personally, and when I was doing this type of research initially. And so progressive web apps are great, and I think absolutely. I think this is, if you're thinking about maybe doing something like this, you should consider a progressive web application. But like with everything else, there's also the element of the requirements piece, right? And you're not working in isolation. And so when we're thinking about this, or when I was trying to think about this, we wanted a solution that allowed flexibility. And one of the nice things about Ionic and capacitor specifically is that it allows you're not limited to anything. You could write plugins that'll give you access to the native data. You could invoke backend services if you so choose that are very customized. And so it just gave us a lot more flexibility. And not knowing where this is going long term, we really wanted to make sure that we maintain the flexibility. But the short answer of it's not an either or solution. I think you could definitely have a progressive web app and still use elements of Ionic to build the UI and have a native looking UI, and use capacitor to integrate natively within the OS. In fact, I think Ionic has the ability, or you can convert an Ionic project to a progressive web app. They have that support.
Interesting.
Yeah.
That's great. Now, so how about this as an ecosystem? One of the questions from Agobin in the chat was about when switching between the mini apps, does it retain session data and data information? I know you had touched upon single sign-on, that sort of thing. I mean, I feel like that's going to be a natural for a lot of people to want to navigate with this. No bad pun intended. But that login that persists to allow you to dip into these different areas and know who you are and not lose sight of that. Has that been a challenge?
I think it has been a challenge, but I didn't touch on that specifically because I didn't want to dive into, like, single sign-on is its own discussion. It could be a whole talk on its own. And so I wanted to focus on how do we maintain a native look and feel and still deliver features dynamically. And this was really the pieces that I wanted to highlight without diving into the details of some of the other technical issues. But I left those also for Q&A, like for this moment. And so it depends how your single sign-on solution at your company or your organization kind of works. And so the best way to describe this really is, I always give this analogy, and I've been trying to explain it. It's when you're securing different lines of businesses, you could think of the building that you're in or your organization. You could use, your access card, and you walk in. When you tap into the building, you either have access to the whole building the moment you walk in and you tap in from the front door, or every floor has its own restrictions and access. And so it really depends on how you've kind of implemented your solution. Like, is your line of business, protected by its own guards and its own set of securities? And so it's not a straightforward solution. You really got to look at how things work in your organization to figure out that part of it. But the short answer of it is, you need to have a token and you need to have a circle of trust. And that circle of trust, you need to be able to allow the communication or the credentials, once they're entered, to be able to be exchanged for certain privileges. And tokens that give you those privileges to be able to call the different lines of business and the services that are associated with them. And so in our case, our lines of business is the latter option, which every floor right now is protected by its own set of credentials. And so a breach in one does not breach all of the different lines of businesses. And so it's a great solution, but it has trade-offs. It's not perfect. And it's something to keep in mind. And so it really depends on your own, but fundamentally you have a token, and that token, you can request privileges and elevate the privileges or exchange it to be able to access the other services that are needed.
That's great. I mean, I'm imagining that, if we were pursuing something like this and we had things broken out by, different kinds of pets. So, we have one login for the main thing, but the dog and cat store is in one mini app, and the elephant feed store is in the other. Can't ignore the elephant in the room. So when you're trying to do that and be able to pass cart information back and forth and all that's that kind of thing, that possible using that same kind of idea? What would you do? Would you hold the information kind of in the main app and then just pass information back and forth between them? Is that kind of the approach you'd take?
Yeah, so with regards to the cart functionality, again, it really is going to depend on your current cart solution. But think of like if you were going to scale this out, you could have a reusable cart function, right? But I would argue and say that probably to start, you're probably going to want the payment information to be provided by the super app. So because you don't want to worry if you're the super app provider and you don't want to have to worry about inventory and checking the pricing and the taxes for the regions. Like it's a much more complex problem, and you should push that to the mini app. Let the mini app developer and that line of business manage and check to determine if there's enough inventory to actually fulfill the order. Because there's a whole backend process with regard to fulfillment and inventory and delivery, and so that part of it is really it could vary across different lines of business. But fundamentally, what I think the goal is to maintain is the payment. Like a user should not have to enter their credit card information 1,000 times per line of business, but have the super app provide that payment, and the mini app requests the payment be made and to acquire the funds. Does that make sense?
Yeah, sure. So there's just a whole slew of questions that keep coming in, but before we get to more of the ones in the chat, we mentioned briefly third-party developed mini apps. Does that change things? I mean, how, like, if you're like bringing in somebody else's stuff, I know you've kind of talked a lot about the isolation of these things for good reason. How much are you like building a whole API at this point in terms of bringing that in safely? Does that really change the way you think about that kind of architecture?
Yeah, I think absolutely. When you walk away from this talk, I'm talking specifically about if you saw the list of the list of mobile apps today, we're in the mini app where it's trusted and it's within the circle of trust for the organization. We have a much more control over what developers do, what they could call, and if something goes wrong, we have direct ability to influence that. And so if you're thinking about opening this up to third-party developers, there's a whole infrastructure that's first required. Like you need to be able to get the package. So how I picture this working is essentially you're building out a Play Store or an App Store where you're going to have to define a bundle structure. That bundle is going to have to be signed and trusted and versioned. You're going to have to push it to your servers. You're going to want to restrict what that bundle can do with your plugins. What URLs and what domains they could load. So there's going to be a whole set of restrictions. And so one of the things that when I was kind of trying to understand third-party mini apps, I actually developed my first WeChat application. And so that WeChat application, they have their own studio. They're in fact not using HTML or CSS. They're using something called WXML and WXSS, which is similar to HTML and CSS. So they've actually restricted the types of tags that you could use within their layouts. And so they have a much more refined control about what users or developers they're allowing them to do. And so if you really think about it, you probably don't want just any API call being invoked within your code or domains being loaded. So there's a lot more control that you'd want to manage over that. The security is really, it's just about the trust. So the main element is going to be around trust. The third is, I would say, session management. And when things are in your organization, you're managing, it's your servers, and how you manage the session between one and the other, you have control over that. When it comes to the third-party developers, you need to probably acquire that bundle, host it on your server, so that way your token could actually manage the access on that specific website or that mini app. Right. So you probably want to host that mini app or the third-party mini app directly. And so there's a whole infrastructure that you would have to really consider and the security and implications behind that. So yeah, it's not, don't walk away from here and saying, I could build, I'm going to let third-party developers come in here. Probably not a good idea.
So shifting a little bit now, I think you sort of answered this in your talk, but James was asking in the Q&A panel, can a mini app be built with native code, or if you want to have it truly cross-platform, do you really need to focus in on that solution with Ionic to really kind of make something that can work in both places, given that Android has one set of capabilities and iOS has another, or doesn't have it, as the case may be?
So sorry, the question is, do we need to build native? I'm sorry.
Well, Ken, I'm sorry, I'm jumbling this up a little bit. Can you build in native code for the mini apps, or does it really need to be one of these starting off with something like Ionic so that it can then run in both environments, given the differences in the way the mobile OSs work?
Yeah, I mean, like, mini apps have a native, like if there's native requirements, like if the mini app needs access, for example, to the camera or sensor data, the way you do that is through capacitor, which means you have to build native code for both iOS and Android. So it's, when the moment you're talking about native capability, there has to be a native layer that you have to build. And it's going to be built for iOS, it's going to be built for Android, and it's going to be built for web. So those three capabilities, you do that through an interface. You define a contract, and that contract defines the inputs and the outputs. And that in itself, once the implementation of that contract is platform specific. So there's an element of Ionic that is not cross-platform, and that is where the native capability is required. And so if you look at one of the diagrams that are in the slides there, you'll see that when you ship the iOS app and you ship the Android app, there's actually the plugins that are sent to Apple, sent to Google. Those plugins are scanned and validated against their security systems, and they're shipped as part of that package. And so you can't get away from that because you need the native capability. But in terms of the UI representation, the look and feel and the transition and the animation, you get a lot of that free from the Ionic UI toolkit. So the answer is,
I think
if you don't want native capability, you could just simply use the Ionic framework or new web technology. But you won't, like if you wouldn't be able to necessarily get dynamic delivery otherwise without Ionic or any web technology. Yeah.
Got it. And maybe that feeds into another question from James about that sort of blank screen as the user navigates between these mini apps. Can you manage that transition the same way you would with native code?
Yeah. So so it's sort of like your splash screen. And so we do have a splash screen that I see there. And there's an element of where you trigger the appearance and the disappearance of that. And so this is managed natively. So that part of it where you're kind of loading that splash screen has to be done natively. And the moment the website loads, then you make that native screen disappear. So you can manage that transition a little bit better than what we did. Mind you, I was on my on an emulator there on my computer, and my computer was a bit choppy there. So.
Oh, no worries. I'm sure that any shade being thrown was being thrown toward your competitors, so don't worry about that at all.
Okay. Yeah.
So another question from Nick. Just the relative advantage of embedding these mini apps versus, for example, linking out to another mobile website. I'm sure that must have been one of the things that you looked at.
Yeah. And so actually, as you saw, that was the first attempt. And so really, it's the idea of, you're taking away the user from the native experience out to a website, and having potentially to sign in again and re-log in. So reducing the friction, keeping the user within the native experience. You have the ability you already know the user's information, you know their data. You don't need to start over. So there's a lot of advantages by having this integration together, where you could share back and forth some of the data, and it just feels more seamless.
So now here's a question that's definitely sort of closer to home for me, from a perv about does Ionic give enough flexibility to extend patterns from a design system, or is it purely an architectural level thing? Meaning, can we use our design system components to render the front end of these things and then have that kind of brought in? I'm not sure how many levels of inception that is if your front end is built in React, but how does that work?
I like the short answer is I feel like the design system work that you have, or like the design system, you could probably pull in, like, for example, on our side, we have, we're using a script to basically pull some of the atomic elements that we have directly into our code. And I think that also our web team is also using a lot of the tools that we have to be able to pull in some of the styles and the spacing and the gaps. But the short answer is I think there's going to be an element where you have to kind of predefine some of these components and then reuse them as you kind of move forward.
Right. Yeah, I feel like that's a challenge really no matter what. I mean, I think if you want to, like, currently, most of our front-end components for the web are done in React, and then we've got different solutions, but both Android and iOS have their own notion of a design system kind of already there. So you're kind of always figuring one way or another to combine these things. So it doesn't sound like it's substantially different or harder. It just also not necessarily easier.
Yeah, I mean, you'd have to use Ionic specific components, right? And those components are already, you could style them and theme them based on whatever it is your style or theme is for your organization or your line of business. So not much changes there. But in terms of how you pull in the styles and things, it would be whatever you currently do to pull in those elements.
So I think that actually plays nicely into a question from Marcus about whether Ionic is sort of the only way to develop the front end for it. I mean, if you, like you're saying, sort of Ionic specific components, is that true, or are there other cross-platform app solutions that you looked at, and Ionic just happened to be the one that you settled on?
Yeah, so we have very clear requirements, right? And so it really depends on your requirements. Like React Native is very popular, hybrid mobile solution that allows that. The problem that we were trying to really solve and the requirements were, we don't want users to download and go to the store and install something. We don't want that. We don't want it leaving a footprint per se on the device, or, and we want it to be able to be snappy. If the user does not interact with that line of business, that's fine. They don't have to have any app installed or anything like that. So we had very, very clear requirements from the user experience perspective in terms of what we wanted. And so it's a process of elimination, to be honest with you. It wasn't like I'm biased towards Ionic or I knew what Ionic was. It was, we started with here are some requirements. How do we make this work? We had, broad conversations about, WeChat's doing this, Paytm. And prior to this project, I personally did not know very much about any of these organizations or what they were doing and how they were doing that. I thought it was cool, but I like, how are they going about solving this problem? And so there was not a lot, as you'll see, if you try to understand and search about the architecture of a lot of these, how Paytm and how they work, it's like a secret sauce. And so, there's not a lot out there that explains how the backend system works. Why don't they just use HTML? Why are they using their own proprietary, or not proprietary? Why are they using WXML or WXSS? Why are they doing that? And so the answers to the why is really it's very puzzling when you're trying to understand how some of this stuff works. But the short answer we had is we knew people were doing it. So clearly there's a way to solve this problem. And so we just basically lined up the requirements, looked at some of the technology, and I mentioned some of them there. And we saw that it was Ionic that basically met almost all their criteria. And again, I already mentioned to you there are trade-offs. It's not a perfect solution, but it met the requirements.
Right. So with that in mind, now that you're starting to work on another project, are there any particular technical challenges you're facing with Capacitor and Ionic together, or do you feel like this is really the toolkit for you and it's giving you everything that you need?
Yeah, I think the challenge comes because we already have some of these lines of businesses and they already have websites. And so the challenge that we're currently facing is we want to leverage as much as possible the code base that we currently have for these web sites that we do have. How can we do that without, rewriting everything? Because a big part of this is, we're already using the technology. Ionic allows you to use Vue, Angular, React, anything that you're currently using. So it's it's agnostic to what your tool set. And so the advantage of it is it allows you to start where you are. And so the idea is, how do we merge the existing sites so that we don't have to rewrite them and from scratch to support Ionic and the Ionic layouts and the buttons. And so I think this is where the challenge is, and understanding how the best way of doing that. It's not easy, but that's what we're struggling with at this point.
That's great. Sorry, I'm just trying to catch up on the questions too, and my head is still just like spinning from all the things that I want to ask you. But I promised I would bring up people's questions rather than completely monopolize the time. So Aghaban had another one. Is Ionic the only super app framework? And whether or not if Uber used that for their implementation. Were you able to kind of piece that out with some of the other apps you were looking at?
Yeah, it's hard to say. If I didn't tell you we were using Ionic, you wouldn't know, right? Like it could have been native, right? And that's good. But you could definitely look for example, in Uber, when I went offline, you just go to your Uber app, go take your put it in airplane mode and check, does the app work? And you could see that there's an element that looks more like a web view than anything. So my sense is they're using something very much like that, where it seems like it's a web technology that renders that. But it's really hard to say. And I think that's what makes this a little bit difficult. And how is this even supported, right?
Right. Yeah, well, that's, from the very first web browser, there is always the option to view source. And it's the way I learned. It's the way everybody was learning at the time, because there weren't any books. There just wasn't anything even written about working on the web. And I feel like there's a level of sort of opaqueness to the app stuff that it's kind of unfortunate in my mind, because I think that kind of takes away from the way the web has always developed and worked, and is a little bit overly protective of that, and it really kind of forces us all to kind of reinvent the wheel a little bit. You touched on that a little bit, talking about which controls you want to have look like your own and which one should really look and behave like a native one. That ripple effect on an Android button versus the way it works in iOS. I feel like it's a really difficult balance to walk. With that, what kind of decisions has your team made about what you want to look purely native versus branded for the client?
Yeah, I think you can have both. It's not necessarily, designing for mobile applications. The buttons could still behave and act as you wish, but there are standards for design, right? It's not like, and I'm not a designer, so I don't want to speak on the designer's behalf, but they have the guiding principles on what each platform, and if you have a designer who works on iOS and Android, they understand that you're not designing for web, you're designing for mobile. And there are, certain constraints that are in mobile that are not necessarily applicable on the web. And so they understand that these things are there. And there are definitely lots of documentation on how to actually design for mobile specific applications. And so you don't have to remove your brand to maintain the consistency with iOS or Android. You could have both.
That's great. Well, we are, I think I've gotten through all of the questions that we have from folks on the side here. There's one other one that's sort of been lingering that I'm curious to know more about, because this is definitely outside the realm of stuff that I've personally dealt with. Have you considered using server-driven UI architecture? And can you talk a little bit first about what you mean by that?
Yeah. So server-driven UI, it's a concept that I first read about, and I was kind of skeptical. Okay, and so server-driven UI, for those who are probably wondering what that is, it's think of it from a perspective that you have the ability to produce the HTML and your data all intermingled. And it's back, like if you've coded in PHP or .NET, those loops that you basically could create and have all the data shipped and the structure of the page, the layout, everything kind of shipped in all at once. And so take that concept and you're going to ship it over to a mobile device. And that mobile device is then going to have to render all of the abilities and the clicks and everything all the events that could happen directly within the mobile, natively within the mobile world. So what that means is you have a markup language. What it would require you is you have a markup language that's custom to your organization, and it would define a header, footer, everything that you typically do in HTML. So you have some type of markup language and the data embedded in it. And then you would take that data, that schema and that layout, you would then send it to the mobile device. It will parse, validate the schema or validate the layout, parse it, and then render the components natively. So you would have like a button that is Android specific, an iOS button. So you would have to have the schema, you would have to have the corresponding mapping of the schema to native components. And so that's what server-driven UI. Essentially, you have the data, you have the layout, and then they're mapped to the native component or drawn natively within the native framework. The issue when I thought about this was that we're reinventing HTML, because HTML is a markup language. It has all the data. It has, it defines very clearly, and it's well documented. And you could take that information and render it in a browser. And so the only difference between HTML and specifically a server-driven UI is you would then, instead of render in a browser, you would render it in the native components directly on your side. So you'd have to have a parser, you'd have to have a renderer, and you would have to basically do that for both iOS, Android, and web. And so I felt that this solution is very complex, not necessarily complex in that it's hard to implement. It's hard to support long-term. How are you going to hire people? Are you going to tell them, please come work on our custom schema? It's very, it's not just a technical problem anymore. It's also about resourcing. Who's going to support this project when you move on to bigger and better things? You know what I mean? And so there's an element of practicality to this. We need to be able to hire people, need to be able to put a post. We could put a job posting and say, if you know Ionic, if you know Android, or you know React or whatever technology you're using, you can hire people for that. You could search and learn online. So it's a lot bigger a problem than just simply making it work as a developer, right? You got to think, how does the organization survive and grow beyond that?
That's a really solid point to end on. George, I can't thank you enough. I, for one, that the video was shorter and we got to have more Q&A. That was fantastic. I feel like we really got to dig into some stuff there, and I really appreciate you spending all the time with us.
Jason, thanks for having me, and thanks to FITC for having me and Loblaw Digital here. Appreciate it.